So here we have a straight horizontal track. Blocks slide without any friction. Block 1 slides next to block 2, which has an initial velocity of 0, initially at rest. It collides with the force probe. It generates a force time graph. So if we have a force time graph, the things we can read from that graph are force and time. The slope, or the gradient, is delta F over delta T, or the rate of change in force. And the area is F delta T, which we recognize as the impulse. And of course, we have our four-way equivalence then. So the impulse is the average force times the time is equal to the change of momentum m delta v. What additional information must be made to determine the momentum of block 2 after the collision? Well, the area of this function, whatever it is going to give us the impulse, which is going to give us the change in momentum. So if we want to know the momentum of block 2, it's going to be equal to the area under that curve. So there is no more information that we need. Now, if we want to look at the other answers to see why they aren't correct, well, we don't need to know the mass if we've got the impulse. And we don't need to know the speed, or the speed of 2 alone won't tell us anything because we would need the mass. And so in either one of those two cases, we need something else besides that, and both the mass and the post-collision speed. Now, that would give us the momentum, but we don't also. What additional measurements? Well, these are not necessary, and it must be made. We don't need to make these measurements at all. We can get everything from the graph.